Hello everyone, so welcome back. So in lecture 1 and lecture 2, we learned what are the different types of operators and their applications. Now here in this particular lecture, we'll try to find out some missing term from given data. Okay, so here in example 1 you see f of x is given and x is also given. So some values of x are there 1, 2, 3, 4 and 5. So they are equidistant. So what is h here? You see from 1 to 2, then 2 to 3, 3 to 4. So h equals to how much? 1 here. Okay. And if you observe f of x carefully, this data is missing here. So when x equal to 4, we don't know the value of what? F of x. So this is, we'll try to find by using what? Operators. Okay. So here mainly we use forward difference operator. But for that particular thing, we need one statement. Okay, now let us see how many different values of f of x are given. So 1, 2, 3, and then what? 4. Okay, 4 values are given here. Now let us see one theorem. You see fundamental theorem on difference. Difference means forward difference. So what it is written here, if f of x is a polynomial of nth degree, then delta to the power n. Suppose it's a polynomial of third degree. Then delta to the power 3 f of x will be our constant. But if we raise the power to 1, suppose if we find delta to the power n plus 1, then it will become what? 0. Okay. So this particular concept we will use here in our problem. So let us see our polynomial is of what degree. So here how many values are given? How many values are given? So 1, 2, 3 and then what? 4. Okay. So 4 values we know. So here f of x is a polynomial with 4 entries, with 4 given entries. Okay, so with 4 given entries. So since there are 4 given entries, so it is a polynomial of degree 3. So f of x is a polynomial of degree 3. So what the fundamental theorem says, if f of x is a polynomial of degree 3, then del 3 f of x will be our constant, is constant. But if we raise the power to 1, suppose 4, del 4 f of x, then it will become what? 0. Directly you can write this one. Or you can remember like this also. Since there are 4 given values of f of x, okay, without writing the first two line, since there are 4 given value of x, so you can directly write delta to the power 4 f of x equals to 0. Okay, now what is the relation between delta and e? So in place of delta, we can write e minus 1 whole cube. So we have already seen in lecture 1 that what is the relation between delta and e. Okay, e minus 1 whole to the power 4. So e minus 1 whole to the power 4. So we have to split it binomially. So what is the first term? E to the power 4, then minus, in binomial theory we have already get it, then 4 e cube, then plus 6 e square, then minus 4e, and then finally plus 1. Okay, f of x equals to 0. So these coefficients, I think you heard about Pascal's triangle, right? So Pascal's triangles also you can directly write. Pascal's triangles are like this 1, 1, 1, then 1. This 1 plus 1 is 2, then again 1, then 1, 1 plus 2 is 3, 2 plus 1, 3, and then again 1. Then always starting number and ending number on 1. Then 1, 1 plus 3 is 4, 3 plus 3, 6, 3 plus 1, 4, and then 1. You see what coefficient we are using here? First, the term is e to the power 4. With e to the power 4, the coefficient is 1. Then we write 4 e cube, then 6, then 4, and then again what? 1. So this is for power 2, right? A plus b whole square. What are the coefficients? A square plus twice ab plus b square. For cube, a cube plus 3a square b plus 3 AB square and then B cube, and 4, these are the coefficients. Okay, so I think you all know this Pascal's triangles from binomial theorem. So using that also you can directly write. Otherwise you can use combination also. Okay, this one no, you can expand like this also. First term is e to the power 4, then 4c1 e cube, then 4c2 e square, then again minus 4c3 e, and finally 1. Like this also you can expand. But I'll suggest you that use binomial coefficients, means Pascal's triangle, then one line you can deduce it. Okay, now let us split it. E to the power 4 f of x, e 4 e cube f of x plus 6 e square f of x, 4 e f of x, and then finally f of x equals to 0. So when this line is clear to all of you, so later you can skip this particular line also. Now, what is the starting value of x? Starting value of x is how much? 1. So we'll take 1. If there are two missing terms, we'll do later. If there are two missing terms, then we have to take the first two values of x, that is 1 and 2. So here, since there is only one missing term, we are going to put x equals to what? 1. Putting x equals to 1. So our above line will become e to the power 4 f of 1. This line also you can skip. 4 e cube. For your better understanding, I am doing in del e square f of 1, 4 e f of 1, and then finally f of 1 equals to what? 0. Okay, so e is our what? Shifting operator. We know that shifting means if the power is 4, then we have to what? We have to give an increment of 4h. Now initially I wrote, see what is h here? H equals to 1 here. So 4h means what? 4 into 1. Okay, 4 into 1. What is the formula for EF of x? EF of x is our f of x plus h. Okay, EF of x is f of x plus h. Then what will be our EF of 1? Here x is 1, na? So it will be f of 1 plus h. And what is h? H is our 1. So it is f of 2. So see, the power of E is 1. And here also we have 1. So this 1 and 1 we have to add. And directly we can write f of 2. Is it okay? So if the power is 2, then it is 2 plus 1. It will become f of 3. If the power is 3, e to the power 3, then 3 plus 1, it is f of 4. So like this, we can write all the terms. So let us take. Okay. So see, here the first term is what? E to the power 4, right? E to the power 4, f of 1. So how much it will be? 4 plus 1. So 4 plus 1 is 5, f of 5. Then this is 3 plus 1, f of 4. So from here, no, after putting x equal to 1, you can directly write this particular line, if you understand. 6 f of 3 minus 4 f of 2. And last term is there is no shifting operator, so it will remain same, f of 1 equals to 0. Now, most of the values are given in the question except f of 4. Okay, so what is f of 1? Just go to the table. What is f of 1? See, f of 1, sorry, f of 5, na? So f of 5, this is our 5. Okay, then what is f of 5? It's 31. Sorry, 32. Okay, f of 5 is 32. Then f of 4 is not given here. What is f of 3? F of 3 will be our 7. Then f of 2 is our 5. And what is f of 1? It is our 2. So from the table, put each and every term except f of 4. And after calculation, that will easily come out, right? So f of 5 is 32 minus 4 into f of 4 we don't know because it is missing. Then 6 into our f of 3. F of 3 is how much? F of 3 is f of 3 is 7, then 2 and then 5. 7, then 3, and finally 2 equals to 0. So if we calculate it, okay, so after simplification, our f of 4 will get. So it will be your 4. Okay, so it's very simple. So which line is important? This fundamental theorem of what? Difference. So since there are 4 entries given, so that's why delta to the power 4 f of x equals to 0. So let us take one more example, then it will be clear to all of you. See, in this particular example, how many missing term are there? 1 and then 2. Two missing terms are there. Okay. Then what? How many values are given? 1, 2, 3, 4, 5, and 6. So we'll write like this. Since 4 values of f of x means what? Entries. Since not 4, sorry. Since 6 entries are given, 6 entries are given, then directly you can write delta to the power 6 f of x equals to how much? 0. Okay. 6 entries are given. So directly we can write delta to the power 6 equals to how much? 0. So again, what is delta? Delta is our e minus 1 whole to the power 6 f of x equals to 0. Now we'll again use those Pascal's triangle, and after applying Pascal's triangle, the coefficients of 6 will be, first term is e to the power 6, then minus, it will be your 6 6e1. Okay, 6e1 is 6 e to the power 5, then again plus, alternatively plus minus, then you will get 15 e to the power 4, and then minus, after 15 you will get 20 eq plus again 15 e to the power 2 minus 6e, and finally plus 1, and then f of x equals to 0. Okay, just now in the previous problem, what are the coefficients of 4 power 4? If it is e minus 1 whole to the power 4, what coefficient we wrote there? 1. You still remember, I guess. So what are the coefficient? 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. So this is for power 4. So if the power is 5, then it is 1, 1 plus 4, 5, 10, 10, 5, 1. But here in our case, the power is what? 6. So if the power is 6, what are the coefficient? 1, 6, 15, 10, 10, 20, 15, 6, 1. So that is what we are writing here. So from Pascal's triangle, you can easily write the coefficients. Okay. Now, since here there are two missing terms, so what I said in the last problem, since there are one missing term, so we have to put x equal to 1. But here there are two missing terms, so we have to put x equal to 1 first and then x equal to 2. Okay, so putting x equal to 1, what will get? See, putting x equal to 1. Okay, if you put x equal to 1, then e to the power 6, 6 e to the power 5, 15 e to the power 4, 20 e cube plus 15 e square, 6e plus 1, then it will become f of 1. Okay, f of 1. So in the last problem, what I told, if it is e f of 1, then the power is 1, 1 plus 1, I will write f of 2. If it is e square f of 1, then 2 plus 1, how much will write? F of 3. So like this, the first term is what? E to the power 6. Okay, e to the power 6 and then f of 1. So I'm talking about this term, e to the power 6 and f of 1. So it will be how much? 6 plus 1, 7. Then next one is 5 plus 1, f of 6. Then 15 f of 5, 20 f of 4, again 15 f of 3, minus 6 f of 2, and finally f of 1 equals to 0. So here see what are the terms that are missing here? F of 3, this is missing, f of 3 and what? F of 5. These two are missing. So you cannot put the values of f of 3 and f of 5, but all the other values you can put. What is f of 8? F of 8 our 512, f of 7 our 343. So you have to put all these values, okay, one by one. So this implies f of 7. So our f of 7 is 512 minus 6 into f of 6. F of 6 will be our 343. Then 15 f of 5. Okay, f of 5 we don't know. So let us keep it like this. Then 20 f of 4. Our f of 4 will be 216. 216. Then again f of 3 we don't know. So it will remain same f of 3. And then so how much it is 512, then 343, 512, 343, then 216 f of 3 will remain same, then 64, 8 and 1. Okay. Then f of 4 we have written, f of 4 we have written 15 f of 4 minus 6 into f of 2. 6 into, okay, I made one mistake. You see, f of 7, na? Okay, f of 7 is 343. Okay. So I had put the value of f of 8. Okay. So let us correct it. So f of 7 will be our 343 minus 6 into f of 6 is 216. 15 into f of 5 we don't know. So let us keep as it is. Then 20 into f of 4. F of 4 is our 64. F of 4 is 64. Then plus 15 into f of 3 we don't know. Minus 6 into f of 3, f of 3 is 8, and then f of 1. F of 1 is our 1 equals to 0. Okay, so except f of 5 and f of 3, all the other values we know. Okay, all the other values we know. So let us solve it. And after solving, you will get f of 5 plus f of 3 equals to how much? 152. Okay, so do the calculation by yourself. Exactly this one you will get. Let it be equation number 1. Okay, equation number 1. So first what we have put there, we put x equal to 1. Okay, now let us put x equal to 2. Putting x equal to 2. In which relation we are going to put x equal to 2? In this particular relation. Okay, yeah. So let it be equation number A. So putting x equal to 2 in equation A. So if we put x equal to 2, then it will be our, see, I'm writing the line so that you'll understand. E to the power 6, 6 e to the power 5, then plus 15 e to the power 4 minus 20 e cube plus 15 e square minus 6e plus 1. Okay, and outside we have f of x, right? So in place of x, we'll put 2. Now see the first term. Power is 6, and here it is f of 2. Okay, so what is e f of 2? Since the power is 1, so 1 plus 2, it will become now 3. So exactly in the same way, here the power is e to the power 6. So 6 plus 2, how much it is? F of 8. Then next will be 5 plus 2, f of 7. Then f of 6, f of 5, 15 f of 4 minus 6 f of 3, and then f of 2 equals to how much? 0. Okay, now we have to put f of 8 as what? See, f of 8 is how much? F of 8 is 512. Okay, 512. So put all the values one by one. Now it is 512. Okay, 512 minus 6 into f of 7 is 343 plus 15 into f of 6. Okay, f of 6 is our 216. F of 5 we don't know, so let us see where it is. Then 15 into f of 4. F of 4 is our 64. Okay, 64 Then 6 into f of 3 also we don't know. And finally f of 2. F of 2 equal to how much? 8 equals to 0. So again, to simplify it, how much we'll get? We'll get 20. No, we can cancel 2. So we'll get 10 f of 5 plus 3 f of 3, and our right hand side will be 1, 3, 3, 1. Okay, this is equation number 2. Now see equation number 1. Equation number 1 is a relation of f of 5 and f of 3. So in equation 2 also we have f of 3 and f of 5. So just what to do? We have to solve these two equations. Okay. So simply to solve these two equations, then our answer will come. So you can do like this: equation 2 minus equation 1. If we do it, then you'll get 7 f of 3 equals to 189. Okay. So your f of 3 will be 27. And if you put the value of f of 3 in either of the equation 1 or 2, then easily we get the value of f of 5. Okay. So let us put it in equation number 1, because it's simple. Equation 1 implies f of 5 will be your 125. Okay. So the problems are very simple. Just what to remember. You see here in problem number 1, how many missing terms are there? Only one missing term. And then how many entries are given? 4 entries are given. So since 4 entries are given, so delta to the power, this delta to the power 4 f of x will be equals to your 0. And in problem number 2, see, 2 missing term are there, and how many value entries are given? 6 entries. So if 6 entries are given, then delta to the power 6 f of x will be your 0. Then after that we use the relation between delta and e, and then we have to what? Simplify. Okay. So I hope it's clear to all of you. Thank you for watching, and kindly share with your friends.